Hello everyone, today we will learn how to design a building for natural ventilation. First, why should we ventilate our buildings? We need to ventilate our building in order to provide a fresh air for occupants. Air indoors can build up a high level of moisture, odors, gases, dust, and the level of CO2. To provide good air quality, enough air needs to be brought in and be circulated so that it reaches to all of the occupants. Most widely used guideline in order to achieve this is the ASHRAE Standard 62. Ventilation rates are communicated using CFM or liter per second. You can notice that different program requires different ventilation rates. For example, lecture hall in here requires more than 10 times the ventilation rate compared to an office space based on the density of occupant inside the space. The second reason for ventilation is for temperature control. Air inside the building tends to be stagnated and become hotter than the outside air. If we are able to push this stagnated hot air outward, bringing fresh and cool air from the outside during the right season, indoor occupant will feel much more comfort and save cooling energy as well. In order to ventilate the building, you can first use natural ventilation, which is the topic of today's class. Natural or passive ventilation is the process of supplying air to and from an indoor space without using mechanical system. People around the world have been accumulating their local knowledge about their own climate to come up with these kinds of brilliant architecture, which are designed to enhance natural ventilation. Mechanical ventilation, on the other hand, refers to exchange of outdoor air provided by mechanically powered equipment. While often scorned for their energy consumption, the mechanical system is not a bad thing. Well-designed mechanical system can be very energy efficient as well. Mechanical ventilation system can provide an opportunity for controlled ventilation even at extreme conditions. Utilizing also energy recovery system can mitigate the energy impact of providing minimum level of ventilation for human and save the energy while using it. Then why should we use natural ventilation versus mechanical ventilation? And why should we not? It is important to remember that this is a complicated problem and you should have clear understanding of the good and bad about natural ventilation before uh, you make a decision to use it. First good thing about natural ventilation is save energy. It is pretty obvious, but the use of natural ventilation requires no electrical energy for fans, which constitute 25% of electrical consumption in the mechanically ventilated buildings. Second benefit is the increased adaptive comfort. In other words, occupants of building prefers to have a control over their environment and prefer not to be completely isolated from the exterior environment. Let's say if you are standing in front of an opened window, the thermal environment is typically more variable and less predictable than those found in air-conditioned buildings. Sometimes it can be even hotter or colder than the normal temperature that you feel comfort when you are inside the enclosed space. But a lot of times, if you are in front of this open window, you wouldn't find it to be necessarily less comfortable. Starting from this notion of thought in the mid 1980s, ASHRAE began funding a series of field studies of thermal comfort in office buildings in many different parts of the world. Since that time, numerous other thermal comfort researchers independently adopted the same procedure for collecting these data in their own field of studies. Based on 22,000 sets of data collected in many different parts of the world, this research has come out. This shows clearly that the occupant of naturally ventilated building are much more tolerant for comfort ranges. For example, if you look at here, um, when the outdoor temperature is at 5 degrees Celsius, an occupant feel for the natural ventilated buildings feel comfort even in the temperature as low as 20 degree, while air-conditioned building uh, needs to be at 22 degree for occupant to feel comfort. It also gives occupant an improved indoor air quality. Research also has shown that naturally ventilated buildings have reduced the problem associated with indoor air quality. One of the most extensive studies shows that the relative to naturally ventilated buildings, the air-conditioned building shows 30 to 200% higher incidence of sick building syndrome symptoms. Then what are the cons? What are the bad things about the use of the natural ventilation? First, it is very much dependent on the outdoor temperature. What will happen if you open a window when the outdoor temperature is too cold or too hot? It will adversely impact the comfort. Second, the movement of air is something that is extremely difficult to predict its performance. It requires a serious level of knowledge, of calculations, as well as technology to control its movement, such as airtightness of the building. This is extremely challenging. Apart from the temperature, there are so many other factors on the outside um, to which you oftentimes want to separate the occupant from, such as outdoor noises, pollen seasons, precipitation, air humidity. It gets extremely challenging to control these outdoor factors coming into the inside of the building. Now, once you understood the benefit and drawback of the use of natural ventilation, how should we design naturally ventilated buildings? It takes three general steps to design for natural ventilations. And each of the steps starts from knowing inside and then outside, and lastly, designing a way to mitigate these two different environments through architecture. First, you need to know the target comfort condition you need to achieve. Second, you need to know what are the outdoor conditions and determine during what period of the time of the year I can naturally ventilate my own building. And lastly, you need to design a building for the proper performance, and we will discuss the ways of doing this on the later portion of the lecture.